I'm Ed Amoroso from Tag Cyber, and I'm here with my friend Andy Prow, who is the co-founder and CEO of a company called RedShield. Very cool company. Andy, nice to see you.
Thanks for having me. So great to see you, Ed.
Good. Hey, listen, we're going to get into tech and talk about the what you guys do, but maybe we start with just a real brief summary of what RedShield does, and then I'm really interested in hearing your story. But what do you guys do?
So what do we do? So shielding is in the name, and that's what we do. We shield what I call high value web apps and APIs. That's our game. And so if I touch on who we do it for, it kind of gives you some context of what we're about. So we're an enterprise play. So we do what we do for governments, for large banks and small. And so the point is, people's internet perimeter today, it's everything you log into. It's the mobile apps, it's the APIs, it's the customer portals. They are the things we shield.
Oh, you're shielding from, say, a malicious actor, from a cyber attack, from malware, those kinds of things. It's security.
Yes, it is. So definitely cybersecurity. But to your point, what do we shield these apps from? So I guess, so we live in a world where, software is moving on at a million miles an hour. People's perimeter is not what it used to be. Everything's in the cloud. Everything's e-enabled and plugged into each other. And so what we do is we shield against the vulnerabilities or the things that people are vulnerable to. So these will be, whether it's authentication, authorization, classic web exploits. There are various stats that suggest a lot of the apps that we push the internet these days are not bulletproof. They're not brand new. They're not shiny. They are full of vulnerabilities. And that's what we shield the applications against them getting breached. So I don't shield you, Ed, the consumer. I shield all the things, hopefully, that you're using. So at the end of the day, I'm protecting you. We're trying to protect the people by shielding the apps you use.
I'm going to guess that you guys are pretty busy because the applications are basically your business now. You used to be that it was physical plant, people. Now
Yep.
it's software, it's applications. It's how we define a business. Andy, how'd you get into this? Tell us a little bit about your personal sort of journey to running this company.
So I'm one of these tech founder CEOs. So in fact, my background personally is software development. So I used to write intelligent networks and telco code for years. We then set up basically a boutique software development company back in the late 90s. So RedShield is actually my fifth company now. So the first three were software development, software consulting. The fourth company we started up was in fact our most successful before RedShield, and that was in fact, it grew to be one of New Zealand's largest penetration testing and ethical hacking companies. So we'd done the migration of being software developers. We'd moved quite hardcore into web application development. So early 2000s, these were the early sort of customer portals, online bankings, these sorts of things built on, whether it was Microsoft's .NET, built in Java. So that was really the core. So we then spent the next 10 years as pen testers. And so from founding that, so it was great to go from software development to software breaking. And so, of course, pen testing, you've got network layer pen testing, then you're hacking and attacking the operating system. But I found the application space was probably the most interesting, because what happens is we'd come along with a pen test and we go, all right, yeah, your network's not well segmented or locked down, but that's a known problem. Locking down networks, you just knew how to do it, you just haven't done it yet. Same with patching apps. So these core applications are missing a few patches. So it's not a hard problem, you just need to deploy the patches. So it's still tricky, but it's a solved problem. So what we then got most juicy was in the application flaws. So this is where the code's broken. And so the code lets you do things you're not allowed to do. And finding problems that didn't go away was really the birth of RedShield. So what would happen here is, you're a bank, you're a government agency, you're big enough that your software is complex, but you're kind of not big enough that you've got all the money to write all the code all the time. And so what happens is, we'd find customers, we'd present you with a pen test, and then we'd come back maybe a year later, and most of the findings are still valid. I'll be like, Ed, what's wrong? This is your customer data. You've still got the same vulnerabilities. What's wrong? And so customers will then say, yeah, but Andy, here's the thing. Either we don't know how to fix the problems, or perhaps we know how to fix it. We just don't have the budget right now. We're focusing on other things. Or this is an end of life system. It's an old SAP, Oracle, whatever it might be. It's kind of end of life. We're just going to have to risk accept these problems for now because remediating them is too hard. So we don't have the budget. It's not the priority. So when we replace it next year, which we actually know with enterprise software is not next year, it's the year after that.
Mhm.
And so this is where we saw a bow wave, particularly in the web app and API space, which is for us at the time, it was the most important. These are internet facing systems that you are not fixing today. And instead it's going on a risk register, and it's just a bit hard. So that was really the birth of RedShield, is what
Yeah,
about all these vulnerabilities people are fixing?
misconfigurations for the most part, or older software, or
Well, so
what
think
kind
of
of problems are you talking about here on the web
so
app?
if you think so software is complex. And so the sort of bugs we're talking about, let's just say authorization. So that's a beautiful arena where, so this is when you've logged in, that's all good, but what are you now allowed to do? And so what happens is the authorization around the data you're allowed to access. Can you edit it or just view it? So you've got role based on your roles inside the organization. You administrator, can you create things, view things? Then down to the data-based authorization. So that's just one tiny section of the web app or the application security space. And yet, so what would happen is we'd come along, the customer's got a great web portal, they've got a mobile app, it's got 200 APIs at the back end, and it's got broken authorization. That the idea is the mobile app is supposed to only let you do things you're allowed to do. But if you can actually run a proxy behind and you do common, ethical hacking pen testing techniques, then you make API calls that you kind of shouldn't be able to. And you find you can access other people's data. You can modify things and see things you shouldn't be able to. And so that's the classic kind of issue where this isn't a configuration problem. This is somebody has de-scoped or forgotten to do basic role and data access authorization across a flotilla of APIs. So that's the problem. So in a pen test, I
Mhm.
can access someone else's data. I can modify data I shouldn't be allowed to. So these are quite fundamental flaws. So hey, Ed, this is now sitting behind your new mobile app that's been live for 3 months. And so what you'll now do as the customer is you'll absorb that. That's a problem. Your security team says it's bad. We've now got GDPR risks. It's HIPAA, it's PCI, whatever our compliance. But I guess actually, if you wind back a few years, when we started RedShield, these compliances weren't as juicy. So what actually happened is in the early days, you go, that really sucks, but no one's breached me yet. And this was pre-GDPR and multi-gazillion-dollar fines. So actually, if I do get breached, it's awful, but I think we can risk accept that, because you know what? Who's going to try? Who's going to do that? This is just some pen tester saying that there's some weird stuff, but actually, it's fine. That's exactly the kind of thing that we find would go on a risk register, because, and this is where we would know it in our hearts. As soon as the customer says, that pen test, our lawyers are engaged, and you go, well, here we go. And why are the lawyers engaged? Well, they've gone back to the vendor to say your software is not fit for purpose. So you're going to patch this, and the vendor's going, well, is it a change request or a bug fix? Because the software is 2 years old, and so if you want us to write authorization, well, that's a change request of the software. We'll charge you a bunch of money for that, versus a bug that we'll fix. And so we know in our hearts, as soon as the lawyers are arguing with the vendor on who's going to fix it, so we're 6 months away from deciding whose problem it is. Then when you've decided whose problem it is, now you might start a remediation. And once the remediation's done, well, now we've got the rollout and deployment of the new software with the bug fixed. So that's a year. Great. So for the next year, your customer records are at risk. And so this is really the world that RedShield was built in, which is we can say in the security space, write bug-free code, patch everything tomorrow. It's easy to say. Enterprises sit down with business systems and use business budget and make business decisions on the risk profile of the applications they're running. And spending $1 million and taking a year right now, when you actually go, once I've removed these security flaws, is my software better? Does it look more beautiful? Have I just got more users? It's like, no, boss. It's the same software you've always had. It's just as bad and crappy as it was yesterday, but now it doesn't have security flaws. And so this is where people be like, I could just risk accept, which at the moment is a great solution. So we actually were born from, if you're going to risk accept it and you're not going to fix it today, how about shielding it?
It makes sense because this problem of software and software vulnerabilities and misconfigurations, even with amidst good advice like from OWASP and other places, they just these are persistent problems. So you're right. Maybe you could argue that the whole security industry, in some sense, is a compensation for existing design and programming flaws. So I think your observations are right. Now tell us a little bit about how RedShield works. How does it, for example, compare with something like a WAF or something that maybe some people watching would
Yeah.
be familiar with?
Yep. That's probably one of the most common questions we get. Isn't RedShield just a WAF? So web app firewall, this is inherently a WAF, is a device you put in front of a web app for the purpose of security. So at face value, the reason you would buy RedShield and a WAF look the same. It's to put some security up in front of your web app. So if you look at it fundamentally, then there is a base level of what RedShield does, which is in fact exactly the same as the WAF. But let's look at, so there's two parts to the story here. One is WAFs exist to block bad things. That's their job. So inherently, so just like a firewall would lock off things, it would close down ports, it would restrict to certain IPs, certain traffic. So WAF does the same. A WAF's job is to look at what's coming in and to go, is that bad? If it's bad, I'll drop it. If it's good, on you go. So the issues with WAFs is inherently you've got that false positive problem. And this is where, we'll touch on, say, some of our machine learning work later. But if you just look at the mathematical problem that says 1 billion requests are coming in, now, if some of them are bad, you must get it 100% correct that you drop all the bad stuff. And if you don't want to affect the user experience, then you need to be 100% correct that all the good stuff gets through. Now, if you're not aggressive enough, bad stuff gets through, in which case you're not a valid security control. And if you're too aggressive, real users can't get in. And so this is where you now get the false positives, and we need to turn down the effectiveness of the WAF. So that's that classic problem where if all you're going to do is block bad, you have to get it spot on, or you'll let bad things through and you'll stop good traffic. So that's just in that problem space. What you also then have is a lot of the attacks that come through inherently don't look bad. So I'll give you a perfect example of, say if you're looking at a DDoS attack where the attackers are now hitting layer 7 DDoS. So this is large volumes of what look like perfectly well-formed traffic. So what you have to do, so that there's nothing bad in the signature, it's just the capacity that's coming through. Or I use as an example the authorization problems I was talking about before. So Ed's logged in and is now trying to do an API call to access Andy's data. Now, from a WAF perspective, the request you've just sent, there's nothing wrong with it. It's a perfectly well-formed request from a logged in session that's trying to access some data. And so as far as the WAF's concerned, what's wrong? What do I block? Because it's not containing any SQL injection, there's no malicious payload, but what you're trying to do is bad. You're trying to break business logic. So that's also an area where WAFs are inherently bad. So the other issue here is, but WAFs tend to look at just this request. So this request coming in, is it bad? But as we know, applications have got a certain amount of, state, that the interactions you've got with that app are going to happen over the next hour. There's, hundreds of requests coming back and forth. And so just to look at it in isolation of this request, well, that's really hard, that the attack may be request 60. So this is where to shield bad stuff at a WAF layer is fundamentally broken. Now, it is key because it's what we call like keeping away the noise. So we'll do the same in RedShield. We will block obvious bad stuff because you know what? That malicious payload that just came in from the Ukraine, your website doesn't need to process that. It's obviously rubbish. Throw that away. So then what happens with RedShield? We've taken a completely different approach, which says, you know what? How about we look at what you're vulnerable to? So if we were to provide you safety on the streets, then to kind of go, Ed, I will block every bad pathogen that exists. That's one problem space. But you'll go, but Andy, I'm allergic to peanuts. So you know what? Right now, I could let in all the pathogens, but as long as I don't let a peanut get near you, you're good. Whereas on the flip side, I blocked all the bad stuff, and then you picked up a nut bar by mistake. Boof. It's like, crap. So this is where what we did is, because of our years of pen testing, shielding is a very, very test-centric approach. So what we'll do with our customers is, if you haven't been pen tested or scanned, we will put up generic flaws, and at this point, we'll look a lot like a WAF because we'll just block the obvious bad stuff. Where the difference is, if you go to your WAF vendor and say, hey, here's my last failed pen test, go crazy and make it look better. Now, WAF will just kind of go, we can turn on our WAF rules. If we fix some of your stuff, that's good. But that's it. You don't give your pen test findings to your WAF vendor. They'll kind of go, yeah, what do I do with it? We're completely the opposite. We want your pen test findings, because what we'll do is we will either have or develop custom shields specifically for your problems. And so if you look at how that works differently, think of RedShield. I often talk to people about, we've got our heads around thin client, fat client. Thin client in the day was very simple. Then we got fat clients, which got highly functional. So a WAF is very much like that thin proxy. It's a proxy layer, but it's very basic. It blocks obvious bad stuff. RedShield is a fat proxy. We actually have code running in the proxy layer. So a shield isn't a regex blocking bad stuff. A shield might actually be a couple of thousand lines of code. The shield actually will have session state of your activity. It knows who you are, knows what your roles are. We may make third-party calls to APIs. So we will call things like, have I been pwned, to see if these credentials are stolen. We'll make calls to verify the validity of certain credit card data. We'll do scanning of uploaded files. So these are things that you do in context. So this is where we actually have security code at that proxy layer. And so we might actually call other APIs. We may modify what you see on the screen. We'll perform a business step, but it's just done in isolation. And the reason we did it is to remove a vulnerability that exists. So now when the bad guys try to exploit, these 2,000 lines of code got released in minutes. They sit in front of your app. They are a shield. Your alternative was to upgrade SAP. So that was one way that you could have fixed this problem, or you could have got a third-party, development company to rewrite some of your code. Instead, the shield goes up. And so in the early days of RedShield, there was a lot of custom shield creation. Now our library has thousands of shields. We've seen so many of these problems all day long that actually now, when you come along as a new customer, we've probably got a shield for that already. And so now this is where the kind of the AI and automation at scale comes in, is how quickly can we recognize exactly your vulnerability on your stack? Do we have a shield that fits automatically, or is there some customization of a shield that's required?
Well, customer doesn't have to sit and learn a programming language here, or learn to write shields. They're probably going to be using ones from your library. That would be the typical experience.
Of course. But what actually happens, we are the shielders. So it's quite different on the outcome based. So this is where in cybersecurity, I often want to beat up our own industry in the sense that a lot of it's so opaque. How do you know if it really works? So I've just bought the security product, I've turned it on, it talks about all this, AI 0-day magic defense is going to do. That's beautiful. I turn it on. And in fact, I often have this challenge to a bunch of CISOs where you'd kind of go, hey, CISO, first of all, here's a piece of paper. Could you just list me down all the security products you own?
Yeah.
Probably not. And then you go, okay, I'll give you a cheat sheet. Here's what you own. Can you tell me what they all do? That gets tricky. And here's the kicker. You go, all right, here's the cheat sheet with all the security products you've got a license to. Here's what they do. Tell me which ones actually work right now. And it's really hard. So
that's where these BAS vendors now are all marketing in that area, where they drop agents and try and validate, whether it works.
Correct. And so this is where at RedShield, we decided from day one, if we can't prove we're working, then we're pointless. So that's the point, is you start from known bad. So let's look at what you're vulnerable to. You're vulnerable to DDoS. You're vulnerable to a bunch of common exploits because you're missing patches. And they're at the infrastructure layer, so they're in the framework, so you can't fix them, or it's third-party code. Now you've got some proper application flaws in your custom code. So we start from that, then shields up. So it's on us to make sure the shields are working. So this is where I'll often describe it as SWAS as opposed to SaaS. So SaaS, software as a service. Now the thing is, you sign up for Salesforce. Does that mean sales come in the door? No, you've got a license to a tool, right? But you still need a sales team. And what I always say with RedShield is, you know what? If you knew how to do this web app and cybersecurity stuff, you possibly would. So we particularly focus on those that are not skilled or staffed to do this 24/7. So in other words, the software with a service it's that enterprise SaaS, which says it's for a monthly fee. It is on us to make sure the shields are up and the shields are working and that you look good. And if at any point a new vulnerability is discovered, you fail a pen test, it's on us to tune the shields to make sure they're good. And so that's that huge difference between, did you buy a tool, which is great, you've paid some money, but does it work? Are you implementing it? Have you tested that it works properly? Do you actually have a team that runs this 24/7? So this is where, to be a security solution, we've gone for the platform that it runs on and the shields that you need with the team that deploys them, and the monitoring to make sure they're up and working. So you actually buy an outcome, which is your site should look clean and secure and not vulnerable to all the bad stuff that's going to happen.
Is kind of the sweet spot here like an enterprise team that maybe has some proprietary app running in the cloud? I'm guessing that would be a pretty common use case. Is that, or maybe there's some other real sweet spot? Give me an idea of what you think the most likely customers are for for
So
RedShield?
if you look at, so that is a key sweet spot where the enterprise team actually does exist. So security is high on the radar. They're big enough as an organization that things like a GDPR fine is actually quite brutal. So they must fix these problems. They can't have it on the risk register anymore. So, okay, it's got to come off the risk register. We've got to do something about it. But to your point, it's third-party code. It is legacy. No one is jumping to fix this right now or to replace the system. No one's got budget for this. That's
I
actually
see.
our sweet spot. Is it's almost you're big enough, and I use the phrase, ugly enough as an enterprise. All I mean by that is you've got time and complexity. So as soon as you're sitting across the table and going, look, Andy, we did a couple of M&As last year. We bought these crowds. They've each got 30, 50, 200 apps that they've got online. We've got all the stacks. We're in this cloud. We're in that cloud. We're on this software base. We're in this software base. All of this is merged together. Check. And so now your exposure. So it's not as though you can just go, oh, let's just quickly update all the apps on our perimeter. No way. No way. You will have. So I guess to come back to that sweet spot question. If you all sit across the table and say, look, Andy, out of the 1,000 apps we've got online, 10 to 20% have got current CI/CD pipelines of, shiny new code. They're good. There's about another 20%, which if we had to, we could redirect project teams to fix these apps right now. But there's probably about 60% of what we got where there is no path to remediation. If that app needed fixing right now, I don't have the team, I don't have the skills. We would have to go out to market to find someone for it. It's out of support. So that's actually one of the sweet spots, is where there is a huge divide between the speed that you can update the apps that are sitting on the perimeter doing critical business roles and the actual security flaws that exist. So as soon as you get this big speed differential, that's the world that we live in. That needs shielding.
That makes sense. Now, how do people buy from you? Do you sell directly to enterprise? Do you sell through channels? What's the best way if someone is listening? They say, well, that's a very cool concept. How do you normally engage with enterprise teams?
So we've actually found, so we'll do a lot of the sales process direct, but we actually work through the channel pretty much exclusively around the globe. And we actually find, so for instance, as you can tell by the accent, we're actually founded in New Zealand, but a large amount of our customer base right now is in the US. And so from that perspective, the enterprise wants to know, it's a ISO 27001 certified environment, and which clouds it's sitting in, and where's the security team? Who do I buy from? I've already got these reseller agreements with, this whole raft of resellers. So that's where we actually transact through the channel. So the rule of thumb is, if you're interested in RedShield, contact us directly. And then what we'll do is we'll work with a customer to go, well, actually, what's the easiest route for you to buy? Because I can guarantee somewhere in our channel and partner list will be someone that you can buy from. So there's the difference between finding out about what RedShield can do for you and how easy it is to transact.
Mm-hmm. And the website is the best place for someone to be in touch with you?
Yeah, look, absolutely. Hit the website, look me up on LinkedIn, flick me an email, sales@redshield.co. That works.
Well, listen, before we close, I got a question I want to ask you. What is your favorite programming language and why?
Favorite programming language. So actually, I'm a hardcore C++ guy. That was, and it's my
Wow,
favorite.
Bjorn Straustrup used to sit right down the hall from me at Bell Labs.
There you go. Crazy world. So look, so I was at uni 91 to 94. So I'm kind of getting a bit of an old bugger now. So to me, that programming language, what I loved about, you're actually doing, pointer manipulation. You're actually accessing stuff in memory. You compiled it. It was kind of real. So that was my background. What's interesting now is, of course, languages have moved on and on and on, and they're more abstracted. But what's interesting is that there's still so much of that kind of, hardcore, say, C++ sitting underneath the covers of things here and there. So I guess that's why it's still my favorite.
You recommend young people start with C++. A lot of people recommend Python, and I guess that's
sure.
That's a nice cousin to that.
Yeah,
exactly.
Well, Andy,
that's it's refreshing to see a technical person running a cool company. I would imagine that probably requires some additional skills that one doesn't learn programming, but you certainly have it. You express yourself so well. Your enthusiasm is obvious, and I'm guessing a lot of enterprise teams probably really enjoy working with your team. So congratulations on all the success.
Thank you very much. And to your point there about enterprise teams, I just want to, so we dived into the tech and how can we help it? You're a techo, I'm a techo, we just go techo brains. But so here's one of the key things though, is that a lot of the time we love to engage in the business teams, because this is where what we cannot deny is that the web apps we now shield, this is core business. We've seen it now with the push in COVID. It's not as though people are accelerating their DX. It's like the horse is bolted, it's gone. So the apps, they just moved to the cloud. We just did it because that's the only, we had to shut down the front of house. Everyone's gone online. So what we've actually seen now is the sudden push of everything online means that this isn't a, have you got a pen test and a vulnerability problem? This is how vulnerable is your business from actually being able to run. And so in many ways, your question before about, who's some of our core target market, it's also those medium enterprises who now their online portal is critical for business. It's how they do front of house with customers. It's how they do their back of house operations. And so from that perspective, the fact that we can just take this problem off your plate, the fact that we are so fast and rapid, so we actually need to be a business level conversation, which is, are my applications and is my online perimeter shielded? And if it's not, give us a call. So of course there's the hyper techos that we'll have to chat with all day long, but at the end of the day, this is a business risk solution. And this is a board level conversation that says, look, if our apps aren't shielded, then they should be.
It becomes part of the digital transformation process that most companies are going through right now. So
that is correct. And we actually have evidence that one of our largest healthcare companies in the US has been the fastest adopter of Azure in US healthcare. And why? Because we literally shield everything that's moving into the cloud. And so it just streamlines that whole process. So if you're trying to migrate something to the cloud, you've got the shared governance that says, look, Azure or AWS or whatever cloud provider will look after your infrastructure layer, but the app is still your problem. And so this is where we've actually got not only huge traction, but we accelerate digital transformation programs. Because the apps we shield just means they can migrate quicker and they now look, modern day shiny security in front of what might not have been quite a shiny app.
Well, Andy, on behalf of the folks watching and certainly my team at Tag Cyber, thanks so much for sharing. I could listen to you all day. This was fun stuff. And I know that a lot of people watching will want to be in touch with you and learn some more, maybe get a demo of the product. So again, thanks so much for the time.
That is wonderful. Awesome. Thank you, Ed. That was wonderful. Cheers.
Great. And for everyone else, we'll see you next time.